Okay, so 2.3, solving right triangles. You have solved right triangles. First of all, we're going to talk about my favorite thing in this whole book. Is it talks about the first Ferris wheel, which was designed and built in America by an American engineer, George W.G. Ferris, in 1893. The diameter of the wheel was 250 feet. So 250 feet across. It had 36 cars. So every 10 degrees there was a car. Yes. 360 divided by. Okay. So about every 10 degrees there was a car. Okay, you're thinking of a car, just this little car, right? Nah. We'll find out about that one. The top of the wheel was 264 feet. So this was 264 feet. So how much is this right here?
What?
The diameter was 250. The top of the wheel was 264 feet. So how far did the wheel go from the ground? 14 feet. Okay. So these are set up for a bunch of application problems you're going to do. You got to read. Okay. It took 20 minutes. 20 minutes to go one time around. Think about that.
Jeez.
20 minutes.
Sounds like fun.
Okay, just wait. It's not even... Okay? As you will see in your progress through the book, trigonometric functions can be used to model the motion of a rider on a Ferris wheel. The model can be used to give information about a position of a rider at any time during the ride. For instance, in the last example in this section, we use the definition 2 for the trigonometric function to find the height of the rider is above the ground at a certain position on the Ferris wheel. In this section, we will use definition 2 of trigonometric functions and an acute angle along with with our calculators to find the missing parts to some right triangles before we begin. However, we need to talk about significant digits. Okay, now I'm going to tell you significant digits is something they worry about big time in science. I don't specifically do because this book makes a big deal out of them and then they don't use them correctly. So this is what I say. If I give you 3 decimal places, you give me what? 3 decimal places. If I give you a whole, you give me a whole. The only thing I say not to do that on is if you were rounding and it gave you exactly 90. Because then you might be making a triangle, a 90-degree triangle, when it is not. Correct? Because I could have a triangle that was like 89.9 and 0.1. That still would be a triangle, correct? So don't be making it 90 if it's not 90. Or don't make it 45 or 30 or 60 if it's not. Because then you make it one of our special triangles when it may not be. Okay? I forgot to tell you how many people fit on one car. Because I made a point of telling you, you're thinking of this little car, right? 40 people fit on one car. Okay, so 40 people, we're talking like huge car, correct?
That'd be like probably the size of this room, wouldn't it?
Well, if they were all crowded in there. I mean, I don't know. But, okay, let's go back to the year. Guys, let's go back to the year. Do you remember what I said?
The people died.
18 something.
1893. So in 1893, you got on this first Ferris wheel that you really didn't know what it was with 39 other people to take a 20-minute ride around a 250 diameter circle.
I think we need to go and be on that one.
How about you let one design?
And it was made of wood, correct?
Oh.
Like it would have had to been made of wood, wouldn't it have?
Definitely died on that thing.
Maybe not, but I don't
think it
know.
would've been fun.
I think
it would be mostly wood.
it would have been mostly wood. I just can't. Can you imagine what the thing weighed?
And I got a picture in the
A
book.
lot.
Too much.
They do have a picture in the book, but it's not. I mean, it's long. The space between the car, like the space between the wheels, is long. See that? But it doesn't even look like they're very open. I don't know.
How much Ford people gonna put on that?
I don't know, but that's crazy.
In
Where was it
20
at?
minutes?
20 minutes it took around to go one revolution all the way around. It took 20 minutes.
There's a ton of carts on there.
Let me see this photo.
Where?
So,
Let's put it in.
where it does not tell me where it was the first at, I'm sure we could find that really easily, but okay.
There's every 10 degrees, so there's 36.
Yeah, there's 36 cars on there. They're not very far apart. Okay, so
Can you please label that 264?
feet.
Yeah. Thank you.
Sorry. Okay, so that's the background. Okay, now we're gonna go back to our simple stuff because that's where we're leading. We will.
Here's what to say.
Not
I wrote
today.
that down so I wrote it down for nothing.
I'm just impressed you wrote it down.
We all
Wait,
wrote it down.
Wait, so you
I know.
just told us
I
about
watched you.
that.
I was like, woo! I was excited.
Okay.
Okay, so I want us to find. Okay, first of all, before we talk, it says in a triangle ABC, angle A is 40, C is 12 centimeters. Find A, B, and B. Okay, so it is important I laid my picture right, correct?
Yes.
C will be always the right angle unless they tell you otherwise. Got it? Now, how did I know that angle A and A go together? Because do they always go across from each other?
Yes.
Yes. Okay, just making sure. So now we need to find everything. I got 12 and I got 40 and I got all my right triangle trig. And I need to find A, B, and C. No, A, B, and B. What do you want to find first?
B, because you would just subtract 40 from 90.
Okay, B, because I just do 90 minus 40, right? So it's 50. That was easy. Check. Now remember, rule is use what you were given, not what you find, unless you have to. Okay? So just because we found angle B doesn't mean we're going to use angle B. Okay. So can I find side A and side B with trig functions with 40 and 12?
Yes.
So if I have 40, 12, and A, what function is that? What are the trig functions, guys?
I'm.
Sine, cosine, tangent? Yes?
Yeah. I was trying to think which one it was.
Okay, so 12 is the hypotenuse, yes? A is what to 40? Opposite. So what function? So sine of 40 equals A over 12. So how would I solve that for A?
Times 12.
Times 12. So A equals 12 sine of 40. So if I don't give you a calculator, that's what you got, right? When I do give you a calculator, you put it all in at one time, not in pieces, ever. Approximately 7.7 centimeters. Guess there was a label on the 12, sorry. I lost today. Okay, you did this in geometry.
B is cosine.
We're going to use cosine now. Why, Jaden?
Because it's.
Adjacent.
Yeah.
because it's adjacent. So I have cosine of 40 equals b over 12. So b equals 12 over.
40.
And make sure you're in degrees because the angle we're putting in is degrees, right? And that is approximately 9.2. Now, if I didn't have the rule, use what you were given, not what you find, could you have just done the Pythagorean theorem once you had A?
Yeah.
Yeah. Now, if you do that, is it going to be exact?
No.
No, not even close to it. Like when we're dealing with little numbers, yeah, it might not make any difference. But if you were really using this stuff for triangulating distances in a plane or a ship or a spaceship or with satellites or with anything of large numbers, would that give me what I wanted? No, you should use the exact. Got it? Because we all know that you guys are going to be aerospace engineers. Okay, so triangle ABC. You will notice most of my triangles all just look the same. It doesn't really matter if they look like mine or they just need to have a right angle, correct? So A, B, C. I expect to see pictures on homework. Triangle ABC, side A is 273. So that goes across from angle A. I said 273, 2.73. And there is no units on this one. Side B is 3.41. That's really hard to say because I want to make it what? What do you think I want to make 3.41?
Why?
Yeah, but it's not. Okay. Find everything else. So what do I need to still find?
Tangent.
I need to find side C and what? Angle A and angle B. On your problems in the textbook, sometimes they say just find one or the other. I'm going to tell you to find everything. I'm going to say solve it. When I say solve it, that means find everything missing. Okay? So now what?
Tangent.
Tangent to find... to find angle C?
Yeah.
Angle C is 90.
No.
I mean,
The line.
what, Jaden? I did not understand what you just said.
So we can find C, Miss Smith.
Thank you. That did not sound like C. Did anybody else think C?
Yes.
All
All of
of
them
something about
are
tangent.
Yeah. Okay. So, but I don't think tangent's gonna find me side C.
Okay, then let's not find C then.
We can find side C, but not with tangent.
Pythagorean.
But the Pythagorean theorem, yes.
I ain't doing that.
Yes.
You're gonna be doing that a lot. So it's bless you. The square root of 340. Yeah, whatever. That squared plus that squared.
See, you know you want to do it.
I can't say it.
Yes, you can.
3.41 squared plus 2.73 squared. Thank you for believing in me, Cadence. Obviously, I'm going to use a calculator on that.
You can't do that in your head.
Not
No.
allowed, Miss Mick.
I can.
Do it then.
11.7.
11.7? No. It's 4.37.
Pretty close.
Okay. Now we got to find angle A and angle B. Now we can use what, Jaden?
Not tangent.
No, now we can use tangent. We can use tangent of A because we're looking right here, right? So tangent of A equals whatever what?
2.73 over 3.41.
Okay, so how do I switch these two? How do I find an angle?
Inverse.
So inverse tangent of 2.73 over 3.41. Let me just tell you what it is.
Yep.
So angle A is approximately And they gave 2 decimal places, yes?
Yep.
That they did.
Oh, we're going to go the nearest 10th. I like the 10th for angles. 10th for angles.
Okay, Miss Mick.
If they don't know, okay, this is what I'm going to tell you. If they don't tell you 10th for angles and 100th for sides.
Okay, Miss Mick.
What's 100th? How many is that?
2.
2. But like this one gave me 2, so I'm going to give it what?
2.
2. Okay, so it is, I think, 38.7 degrees. And the reason why we go 10th is we're not making anything what it's not, right? When I talk about that.
Yeah.
Okay, so now I'm going to do B. What are you going to use with B? What?
Tangent.
Tangent. So the tangent of B is what?
3. 4. 1 over 2.73.
So we're going to do the...
Inverse.
Now, I would expect after today you wouldn't even do this first step. And would that be okay? Yeah,
Yeah, that'd be okay.
it would be okay. So angle B is approximately 51.3 degrees. Could have also just subtracted from 90.
Yes.
Yep. But what if I screwed up A? Then what would that do with that?
Be in a shenanigan.
I would be in a shenanigan. Should I take a minute to make sure that these two added together equal 90?
No.
Yes.
Miss Mick, do they equal 90?
Well, 3 and 7 at least equal 10, right?
Yes.
Okay, so then this makes that a 2, and 2 and 8 is 0, and 3 and 5 is 8, plus 1 is 9.
What? You did that in the most difficult way possible.
That's how my brain works.
For the best, Miss Mick.
You do it in a video, right?
Yeah.
Okay.
So, do it.
Ooh, this is going to be fun.
It was 90.
Guys ready?
Say it's
You
fun,
look
it's
at
not.
it, you see the
Yeah.
numbers.
Okay.
It equals 90.
It's not a circle.
Circle. You got to draw a good circle like that.
I'm looking
Miss
at
Mick, that first
Miss
circle
Mick.
you made, what was that? The Ferris wheel?
What was wrong with it?
Go back.
Everything.
It was a little lopsided. Hey, that one's pretty good, though. I bet yours
Ferris
isn't that
wheel is
good.
a little lopsided.
All my circles I've ever made have been lopsided.
Just like you would.
It's not that good.
Okay, man.
My Ferris wheel one?
This is why I hope you lose tonight.
Savannah is like already shutting the video off.
You shut the video off.
No, it's recording. Okay, so we have this picture. They will give you this picture, but I would suggest you write it on your paper so you can manipulate it.
It's a little duck.
Okay, the circle in the figure 3 has a center C. Has a center C and the radius of 18. So the radius is here, but it's also where?
Everywhere around the circle.
Isn't it there?
Yeah.
From here to here? Okay. If a triangle is a right triangle, A is 35. This is A, so I guess that's B, huh? So it's 35 degrees. Find the X, the distance from A to B.
Right.
So we're going to have some steps on this one. It is not going to be just solving a basic right triangle. We have to do some work. Oh, wait. I labeled wrong.
Not your dog, Miss Mick.
I labeled wrong. B is here.
Oh. Ooh. Strong.
Outside of the circle?
Right.
It's that point on the edge.
Messed up.
Okay.
It's the point right here.
See, the whiteout's so good you can't even tell where she messed up.
Hey, give me some of that.
And so this is D. I'm trying to use these because I haven't been using them. They're drying up. Okay, so I need to figure out that, yeah?
Yep.
Yeah.
Okay, so parts of the right triangle that we want and have. So I have 35 degrees.
90.
Okay.
You know it's 18.
I know the what of 35 degrees.
It's length. It's opposite.
It's opposite. Thank you very much. And this side is the what?
Hypotenuse.
Hypotenuse, yes?
Yes.
So what function are we going to be using?
Tan sine.
Sine. So I'm going to have the sine, and Jaden's running off on me, because sine starts with a T now. Sine of 35 equals what?
18.
Over
X.
35.
Wait,
No.
18x?
B.
Sorry.
18 times x
No, plus x.
plus x. So I need to do some math, right?
Yes.
Right.
So I have to multiply both sides by this quantity.
Yes.
Well, I got to get to the x, so before I can get to the x, I have to distribute.
Yes.
Yes.
So that gives me 18 sine of 35 plus x sine of 35
Yes.
equals 18. So do not get hung up on how big or whatever. Just focus on what am I solving for?
X.
X. So I need to get x all alone, yes?
Yes.
So I have to start by subtracting this, correct? So I have x sine of 35 equals 18 minus 18 sine of 35. Okay, then what?
Divide by sine of 35.
Divide by sine of 35. So x equals 18 minus 18 sine of 35 divided by sine of 35. Now remember, just going to stop some things from happening. This is one quantity in the numerator, so I can't go and reduce, can I? This is it. Now I have to put it in my what? Calculator. Now, the calculator will follow order of operations. If you just put 18 minus sine of 35 divided by sine of 35, it's going to do division first. So what do I have to do to make sure it's not going to parentheses? So I want everybody to be putting this in their calculator so they make sure they get it right. So be parenthesis 18 minus 18 sine of 35 divided by sine of 35.
Yes.
Well, how many decimal points would we give it now?
Well, they gave you a whole number, so you should probably give it a whole number, huh?
So 13.
Yep. And we don't say equals 13, we say what? Approximately 13.
Miss Mick, why'd I get 0.0000?
Are you in radians? Check your mode.
I'm in degree.
You probably just put it in wrong.
Okay, did you put parenthesis 18 minus, does yours look exactly like mine?
Did you double parentheses?
Like here?
Oh, I did 2 there.
You should have 2 there.
No, I mean in front of it.
Oh,
There's 2.
yeah, no.
Dummy.
Did you get yours, Riley?
Yeah.
Okay. Now, we didn't get to examples for, well, we only didn't get to one example. It is on page 74 if you want to look through it. I want you to try the problem. We'll go through it on Monday. Okay?
Okay.
We were a little distracted today with me dying and everything.
I believe